مرحبا. So رح أبدأ أحل هلا ب question number 2. So basically question number 2 رح يعطينا أو بيعطينا a CMOS inverter circuit. This CMOS inverter circuit is made out of a PMOS and an NMOS. So knowing that the absolute value of V threshold P is equal to V threshold N, and they're both equal to 1 volts, we have the values of Kn and Kp. Also, the values of W over L for N and W over L for P, and they're equal to 10. We need to find V output when V input is equal to 0 volts. So V output is right here. We need to notice that V output is connected to the drain of P and the drain of N. And here we input the voltage. And also we need to notice that V input is connected to the gate of the PMOS and the gate of the NMOS. And the source of the PMOS is connected to a voltage VDD. And the source of the NMOS, so the source of the PMOS is connected to VDD, and the source of the NMOS here is connected to ground. Okay, so if we input a voltage of 0, so if V input was 0, if V input was 0, it means that the voltage at the gate of the PMOS and also as well at the gate of the NMOS are both 0. So V at the gate of N is equal to 0, and the voltage at the gate of the PMOS is equal to 0 as well. Therefore, if you want to find VG source for P, we need to subtract the voltage at the gate, which is 0, minus the voltage at the source, which is VDD. So 0 minus VDD equals minus VDD. Minus VDD is less than V threshold P, which is equal to minus 1. So minus 5 is less than minus 1. This makes the PMOS on, because the absolute value of VDD is greater than the absolute value of V threshold P, which is 1. It's minus 1, but the absolute value is, it's minus 1, yeah, but the absolute value is 1. So this PMOS is on, whilst the NMOS right here will be cut off, because V gate source of N will equal voltage at the gate, which is 0, and the voltage at the source, which is also 0 because it's connected to ground. Meaning that it's cut off. So it acts like an open circuit. It acts as an open circuit. So the static current I at P will equal to I at N, and N is cut off. So the current will equal 0, meaning that there is no voltage difference between this point and this point, therefore current does not flow. So VDD minus V output equals 0. Therefore, V output equals VDD and is equal to 5. This is how a CMOS inverter circuit inverts the input from low and to high. So if we input a low voltage, then we have a V output of high. Another way to prove that V output right here will equal to 5 is that let's assume, since this PMOS is on, let's assume that it's operating in saturation. So IFP equals half capital K of N a capital K of P, I'm sorry, where Kp capital is equal to W over L of P by K small p. So it's equal to half K of P V gate source minus V threshold all squared. So V gate source equals minus VDD, and minus V threshold, it won't equal 0. So we know from here that the PMOS is not operating in saturation, so we can't use this. So if you assume that it's in the triad, so if it's on, but it's not in saturation, then of course it's in the triad region. So I of the PMOS in the triad region is equal to K capital of P. Okay. V source minus V threshold V drain source minus V drain source over 2 squared. So we know that Kp does not equal 0, but Ip equals 0, and this also does not equal 0. So V drain source at the PMOS must equal 0. So VDS of P equals 0, which means that V drain of P minus the V source of P equals 0. The drain of P is connected to V output. So V output minus V source of P equals 0. So V output equals V source, V output equals voltage at the source of P right here is equal to 5 volts, which is VDD. This is another way to prove that if we input a low voltage of 0, then the output will be 5. Will be VDD, in this case it's 5. Okay, so to solve V, which says that V input equals 5 volts, we input a voltage of 5. In this case, V gate source of P will equal 5, which is the V input, minus VDD, which is also 5, and will equal to 0. Zero is less than V threshold P in an absolute value, of course. Therefore, the PMOS will be cut off. On the other hand, the NMOS so the voltage at the gate of the NMOS is 5 volts. And at its source, it's connected to ground, so it's 0. So V gate source of N is equal to VDD, and it's of course greater than the threshold of N, which is 1 volt. So 5 is greater than 1. That's why it's on. So this NMOS is on. This PMOS is off. So no current is flowing through N because it's cut off. No current is flowing through P because it's cut off. So the current equals 0. So V output will equal to 0. Because there's no way, because this operates as an open circuit, the PMOS operates as an open circuit, there's no way for the voltage right here, 5 volts, to to pass through the output. So another way to prove that V output in the case of a V input of 5 will be 0. We said in the first case that there's no way for this 5 volts to pass through here, since the NMOS is connected to ground, and this here is an open circuit, V output will be 0. So let's assume that this NMOS is operating in the saturation region. So I of the NMOS in saturation equal half K of N V gate source minus V threshold squared. But V gate source minus V threshold does not equal 0. Therefore, N is not operating in saturation. So it's operating in the triad region. V gate source minus VT by V drain source. So the value of K of N equals W over L of N, K small of N. Okay, so it does not equal 0, of course, but I equals 0. VK source minus VT equals VDD minus VT. It does not equal 0, so V drain source of N must equal 0, meaning the voltage at the drain of N equals the voltage at the source. So the drain of N is connected to V output. The voltage at the source of N is connected to ground, so it's 0. So V output equals 0 volts. This was the other way to prove that if we input a voltage of 5, the output will be 0. So زي ما حكينا if V input was 0 volts, V output will be 5 volts. And if V input equal 5 volts, V output will equal 0 volts. Okay, so this was question 2. Thank you very much for listening.